Hi, good morning. So here I am going to discuss about least square curve fitting. So our aim is the force F required to pull L are tabulated below. If F and L obey linear relationship, find the force needed to pull a load L equal to 150 kilogram. So we have to find the force required to pull a load L equal to 150 kilogram, and here we are using least square curve fitting to find the force. And the theory is the method of least square is probably the most systematic procedure to fit a curve fitting, and it is widely used in practical computations and also can be easily implemented on a digital computer. So we have a set of data points xi, yi, where I equal to 1 to 3, 1, 2, 3, etc. to m, and let the curve is given by y equal to f of x, and that is to be fitted to this data. So at x equal to xi, the observed value of coordinate is yi, and the corresponding value on the fitting curve is f of xi. So if ei is the error at x equal to xi, then we have ei equal to yi minus f of xi. So s equal to y1 minus f of x1 square plus y2 minus f of x2 square plus etc. plus ym minus f of xm square, or we can write it as e1 square plus e2 square plus etc. plus em square, that is the square of the error. And to fit a straight line, we know that the equation of straight line is y equal to mx plus c, or y equal to a0 plus a1x, and which is to be fitted to this given data. Then s equal to y1 minus a0 plus a1x1 square plus y2 minus a0 plus a1x2 square etc. plus ym minus a0 plus a1xm square. So to minimize this, we have to find ds by da0 and ds by da1, and we get the equation as ma0 plus a1 into x1 plus x2 plus etc. plus xm equal to ym plus y2 plus etc. plus ym, and a0 into x1 plus x2 plus etc. plus xm plus a1 into x1 square plus x2 square plus etc. plus xm square, which is equal to x1 y1 plus x2 y2 plus etc. plus xm ym, or it can be represented as m a0 plus a1 into sigma xi equal to sigma yi, and a0 into sigma xi plus a1 into sigma xi square equal to sigma xi yi. So these equations are called normal equations. So from this we can find a1 and a0, that is a1 equal to m into sigma xi yi minus sigma xi into sigma yi divided by m into sigma xi square minus sigma xi the whole square, and a0 equal to mean of y minus a1 into mean of x, and this shows that the straight line is passing through the centroid of the data points. So our algorithm is, first we have to start and read the members of data points n, and put the value of p as sum of x, and q as sum of y values, and r as sum of x squares, and s as sum of xy values, and start the for loop, that is for I equal to 1 to n, and read the pairs xy yi, and p equal to p plus xi, q equal to q plus yi, and r equal to r plus xi square, and s equal to s plus xi yi. Then end the for, and m equal to, that is slope m equal to pq minus ns divided by p square minus nr, and the y intercept c equal to ps minus qr divided by p square minus nr. And after print the slope and the y intercept and plot the xy values, and we have to find the force required to pull the 150 kilogram, that is load. So for that, read the z, that is the x value, and the solution as mx plus c, and print the corresponding value of y, and that's all. That's the algorithm of our program. And our program is from pylab import n equal to input, enter the number of xy pairs and print enter the percentage d xy pairs percentage n. So this is used to print the number, that is percentage d xy pairs, and xy equal to input for I in range of n, and x equal to float of xy into I into 0 for I in range of n, and float of xy I into 1 for I in range of n. Then after that, sum x equal to sum of x and sum y equal to sum of y. Then sum xy, that is sum of x of I into y of I for I in range of n, and sum x square equal to sum of I into I for I in x. Then the denominator, that is den din equal to n star sum of sum x square minus sum x into sum x, and m, that is slope n star into sum xy minus sum x into sum y divided by float of denominator. Then c equal to mean y minus m star into mean of x, that is y intercept. Then print the slope m equal to, then float of m, and y intercept c equal to c. Then dx equal to max of x minus minimum of x divided by float of n, and dy equal to max of x minus minimum of y divided by float of n. Then the axis minimum of x minus dx, maximum of x plus dx, and minimum of y minus dy, and maximum of y plus dy. And we have to put the title as least square fitting. So title of least square fitting, and x label as x axis and y label as y axis. And for I in range, plot x of I, y of I, and b star, and this the equation of straight line, that is y1 equal to m into x of I plus c for I in range of n, and plot the x y1, and z equal to input value of x. So here we can put the value of x as 150, and we get the corresponding value of y, that is print the corresponding value of y for percentage f is percentage z float of solution, then show it. So we get the output as like this. So enter the number of xy pairs, that is 5, and enter the 5 xy pairs. So we get the force and the load. We have the force and the load, that is 50, 12, 70, 50, that's the pairs, that is 100, 21, 120, 25, 140, 29. So the corresponding slope of that equation, that is m equal to 0.1913533834459, and the y intercept c is equal to 2.0300751877, and the value of x equal to 150, and the corresponding value of y for 150 is 30.73082706766915. So we get the graph as like this, that is a straight line. So that's all. Thank you.